All right, we're going to have a look at doing the interpenetration of these two pipes. You've got a main pipe, which is a hexagon, and you've got a branch pipe that is also a hexagon. Drawing that, the side is 20 millimeters, so you set your pair of compasses to a length of 20 millimeters, and you draw a radius with that 20 millimeters, and you can get that hexagon. You've got a line over here, you mark it off at 30 millimeters up from there, and you can draw that 45-degree line coming out. Draw a circle with a radius of 15, and you should be able to draw in that little hexagon over there. You'll see that I have drawn a little line coming out over here, as they indicate, and you've got a line that comes down at 45 degrees there, and you can then draw these lines coming down to make your branch pipe coming out of the main pipe. Right, once you've done that, I start out and I number this thing. I've got number 1, 2, 3, 4, 5, and 6. And you can see that I've transferred those numbers onto this face over here. Number 1, 2, 3, 4, 5, and 6. Easy enough. I want to draw a line coming out over here, and I draw an auxiliary view over here. And I need to put numbers onto that. What I'm going to suggest is that you take this down. There's number 1, comes down over here. There is number 1 on this view over here. Number 1 on this view means that I will have a number 1 on that side over there, and this point over here would then be number 4. I then come over here and I say, all right, where is number 2 on this thing? Okay, if you look at it, number 2 would be closest to an XY axis over here, so I need to have 2, which will be over here. If I've got that, then I know that that must be number 3. There is number 4, 5, and 6 over there. Right, once I've done that, I can then draw in my lines going around this thing. There it is. And I can draw in a line that goes all the way across there, and a line that goes all the way across there, and a line that is going to go over here. They have got it in hidden detail over here. I'd prefer you actually draw a dark line, but put the hidden detail because they've done hidden detail. It is meant to be a pipe, which means that I would actually be able to see that line. If they put hidden detail in, you put hidden detail in. Right, over here, that would be number 1. That would be number 2, you can see over there. That would be number 3, 5, and 6 over there. Right, once I've done that, I now need to try and find the curve of interpenetration of these pipes. And you can see number 1 coming down over here, that would be point number 1 touching over there, and I've got point number 1 touching over there. If I come down over here, that would be number 4 at the bottom. Number 4 at the bottom, also touching over there. I need to find out where number 2 is. Number 2, I'm going to take a line coming from where number 2 is touching over here, straight up into my picture, into my front view. There it is, and number 2 will be at that point over there. Right, you can see number 2 coming down, connecting with number 2 going up. Number 3 is on that same line, so there's number 3 coming down, and I mark number 3 over there. Please use these numbers, it is very useful. I also have number 6 coming across. Okay, number 6 is over there, comes across, and you'll see that it also links up with number 2 and 3. So 6 will be on that point over there on the front side of number 2. Number 2 would be at the back, number 6 is at the front. Okay, number 5 over here would be on the same point as 3, but in front of number 3. So there's number 5, there's number 5 coming across, there's number 5. Make sure that you put in all of these numbers. There is number 3 over there. And you can now join that up. I have got a line. If I was drawing this in just for number 1 to number 2, it would be a hidden detail line. But I have this line from number 1 to number 6 over here, which would cover that hidden detail over. I'll obviously be able to see this line, number 5 to 6. That's right at the front over here. You can see it's a point view over there. So I've got a line coming straight down. And I have got a line that is going to go across from number 5 to number 4 over there. I also have another line that would be in hidden detail going from 4 to 3. Another line going from 3 to 2 in hidden detail, and hidden detail going from 2 to 1, but we can't see that. I need to draw in these lines over here, coming down. And once I've done that, I can start doing the branch pipe. I'm going to start with the branch pipe from the, doing the development of the branch pipe over here. I'm going to take lines coming out at that 45 degrees from the base of the branch pipe and then from the curve of interpenetration. There is number 1 going across, number 2 and 6 going across, number 3 and 5 going across, and number 4 going across like that. Once I've done that, I'm going to draw a line, just a construction line going up over there, and I now take this measurement over here. This over here is a true length of the base of that branch pipe. Why? Well, if I had an XY axis, you'd see that that line over there would be parallel to the XY axis. Therefore, all of those lines would be true lengths. So I take the true length of the side of that hexagonal pipe and I go 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. Okay? Note this. Number 1, I'm going to start over there. Number 2. Number 3, number 4, number 5, number 6, and I go back to number 1 over there. That gives me my 6 sides. If I fold this thing, I'm going to end up with 1 going back to number 1. I can draw in the little side there and there. How did I get that? Can you see the true length distance that I've got of 1? Okay, if you think of it, this is showing me, I'm going to call it number 1 at the top and then 1A at the bottom. Let's call that 1A at the bottom, 1A at the bottom. That would be a point view, therefore I've got a true length distance over there. Right, number 2, you can see where number 2 is coming across, and I draw a line coming out to meet number 2, and number 6 as well has the same length as that. There's number 3. Right at the top there, so I go all the way out to that point over there, and number 5 has that same true length. And then number 4 goes to that point over there, and I can now draw in these lines joining these points up quite easily. There we go. Make sure you work incredibly accurately here. Obviously a mask will go over this. Make sure that you get the lengths of side very, very accurately done. And I will actually talk about doing that even more accurately in the next one. Right, I must also draw in a line that goes over here. And then you must label this as the branch pipe. Okay? Development. Of branch pipe. Okay, don't forget that label. You get lots of marks for it, so don't put it in. Don't not put it in. Right, okay, I'm going to take a line coming out from that. And something I would like you guys to do, I know that length of side is 20 millimeters. Now, what often happens is that, yes, I know that I can take an accurate measurement of 20 millimeters, and I can come over here and I can mark that 20 millimeters off the 6 times. Unfortunately, what happens is that you end up with those marks not being exactly where they need to be. So possibly what you should do is you say 20 multiplied by 6, and that is going to give you that 120 millimeters, and you can then measure that off more accurately. Okay, 120 millimeters, is that right? 6 multiplied by 6 multiplied by 20, that's going to give you 120. Measure that off over there. Okay, so I've got that point over there, that point over there. That's 120 millimeters. And what I would suggest you do is you actually break that line up equally using that technique that we learnt with just sliding the rulers together. Draw a line out at any angle. Mark off your 6 spaces. 1, 2, 3, 4, 5, and 6. And you can then break that up very easily using your set squares. Right, so you just take that, 2 set squares together, and you are going to then slide that across. There's that line. There, 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 and there. That gives you a far more accurate hexagon. Okay, so we've got a true length over there of these sides coming around. I'm going to label these things as A, B, C, D, E, and F. Okay, and I start out with this point over here. I'm going to call it point A. Okay, and I draw some construction lines coming up from A, construction line coming up from B, C, D, E, F, going back to A over there. Let's label it A, B, C, D, E, F, and A. Okay, and now I say, all right, what is happening on line A? Well, there is line A over there. That would be B and F over there. That would be C and E over there. And that would be D over there. Right, A and B and A and F, those 2 sides over there, you can see the curve of interpenetration happening in there. This line B and this line F, they're not touched, nor is E and C or D. So I can draw in those lines straight away. Just draw in this true length line over here of B. I can draw that in, no issues. C, same story, I can draw that in. D, I can draw that in. E, I can draw that in, and F, I can draw that in. Note, I'm not drawing in A because I have that cut that's going to happen in there. I can draw the top in over here. There it is. And now I'm going to do the curve of interpenetration on that development. Right, there is number 1. I know that number 1 is touching that line A, so I can take it across and I can draw in number 1. There is number 1 on that side, but I also have number 1 on that side. So I've got point number 1. Label it, people. It is worth your while labeling it. And I know that I have a line that's going to come down to where number 1 is, and a line that comes down to where number 1 is. I can see number 4 over here is also touching line A, so I can take that across there and across there, and I can label those 2 points number 4 and number 4. Put this line in over here and put that line in over there. Right, the next part gets a little bit more complicated. I'm going to start looking at this particular portion between A and B. Okay, that's this little section over here. And you can see that I've got a true length line going from point A to where 2 and 3 are touching at the bottom. Okay, I'm going to take that measurement, that true length distance, and I'm going to transfer that down to the base over here. And I have got point 2 and point 3 over there. I'm going to take that line going up from that point that I just made on the base, going up over there, and I can now take lines coming across from 3 over here, and I can mark that off as 3, and I can take a line coming across from where 2 is intersecting there, and I can mark that off as point 2 over there. Right, once I've done that, I can now draw in a line which goes from 4 to 3, a line that should go straight up from 3 to 2 over there, and a line that is going to go from 1 to 2 over here. Now I have a look on this side. You can see between A and F, there is my point A to F, and I have that curve of interpenetration in there. I'm going to take this true length distance now from A to where 6 and 5 is. Okay, I come along here, I mark that off. There it is. There is the mark where point 6 and 5 will be, and I can take a line that is going to go up over there. Take a line going up, and I'm going to take a line that's going to come across from point 6 over here, across where it intersects. That is going to be point 6, and if I come down over here, there is point 5. Take that across from there, and you can then mark that as 5. Once I've got that in place, I can now draw in a line that goes from 4 to 5, 5 to 6, and from 6 to 1 over there. Don't forget to draw in the baseline of this thing. Very often that gets left out for some reason. And you need to label this as the main pipe development. Development of main pipe. All right, that should get you all the marks that you need for that exercise.